So today I want to look at types of attractive forces, and these are like what determines like the melting point, boiling point of a lot of substances and how they react. And so just a kind of review. The first type is ionic. Again, this occurs between ionic compounds. Always remember, like opposite charge attract, I should say. So if I have sodium chloride, and again, if you have salt, you have like these billions of sodium chloride formula units together. It's always the positive and negatives are attracted to each other. So if you ever see a positive, it's going to be a negative, etc. These are very strong forces. So these ionic forces, these are the strongest type of intermolecular. And really what I should say, intermolecular is between molecules, or in this case, between ions. So these are intermolecular forces. So if you have an ionic compound, basically you say ionic forces are going to be the ones in there. Those are the strongest. Now, if you have polar compounds, so these are for polar, you have two choices, either hydrogen bonded or dipole-dipole. Hydrogen bond is very specific. It's a very, very strong interaction between a hydrogen and a fluoride. So if I have hydrogen fluoride and I have another molecule coming in, the intermolecular forces now, it's always going to line up now. And this is the intermolecular force right here. It's that dashed line. Now, between a hydrogen and fluoride itself, between that molecule itself, that's called intra. Those are much stronger, but we're looking at the ones in between. So you're going to have to break these bonds. Again, in this case right here, you have a fluorine molecule, and they line up like this. And this is why water has, the fact that water at the ice, the solid form of water, is less dense than the liquid form, which is the opposite in most cases, because of this hydrogen bond. And so for hydrogen bond, no, very specific between hydrogen and fluorine, hydrogen and nitrogen, and hydrogen and I should say oxygen. Sorry, there we go. So hydrogen, fluorine, hydrogen, nitrogen, and then hydrogen and oxygen. Very, very strong dipole-dipole. So for water, so positive. This is a positive, negative. Another water molecule comes in. It's always going to line up to the oxygen. So again, it's always positive and negatives are going to be attracted to each other. So ionic compounds, ionic forces, hydrogen bonding only between H and F, H and N, and H and O. So it's only between these three types right here. So 3, 2, and 1. You see an OH bond, like for alcohols. This is for alcohols. That's hydrogen bonded. So the way to remember now, alcohols, hydrogen bond, because you have that OH type. Something like ammonia. So ammonia has this formula right here. It's going to form hydrogen bonding. So another ammonia molecule comes in. It's always going to line up positive and negative. Just remember that. Again, it's these bonds right here. That dashed line is the intermolecular forces. These are the stronger. So the dipole-dipole, ionic is the strongest, then hydrogen bonded. Dipole-dipole is between polar molecules, but it doesn't have HF, HN, and HO. So hydrochloric acid is a classic example. Again, it's that dashed line. This is dipole-dipole. Last type is called dispersion. These are between nonpolar molecules. So if you see a carbon-hydrogen bond, that's going to be a dispersion type interaction. Again, nonpolar, you don't have a positive and negative. Dispersion, you have like what we call an instantaneous one, because these molecules are always slashing around these electrons. So if I have you can have like an instantaneous dipole. So this is called like an instantaneous. Only for a fraction of a second. And then another iodide will come in and kind of line up with that. These are very weak. So to finish it off, we'll say ionic is the strongest. Hydrogen bonding greater than dipole-dipole. Greater than dispersion. One last thing to finish off is that ionic is for ionic compounds. Hydrogen bond and dipole are for polar. So if you see a polar compound, you gotta make a decision: hydrogen bonding or dipole, and then dispersion is for non-polar.